Hello, this is the Tepid Coder. This time I want to make the file parser I already made in C. Well, yeah, basically in C. I'm compiling it as a C++ file, but I'm not really using any C++ features. This time I'm going to do it in C++. I'm going to show how it can be advantageous to use some of the containers. So I'm going to take the previous file that I was already working with. I'm going to save some of this stuff. I'm also going to delete some of this stuff. I'm going to add some new container types. So we're going to add the string container. We're going to add a vector container. And let's see, anything else I want to do here? I'm going to leave that the same, yeah, okay. I'm going to leave this the same. I'm also going to type dev it just like it is. Since we're doing C++, you can actually initialize values inside your structures. So I'm going to say each of these is 0. In fact, I can do even better. I can say standard string key, right? Well, stir key. And I can say standard string stir value. And those will automatically be initialized to 0 when you make a new instance of the structure. In fact, I can even do better than this as well if I want to. I'm not going to yet. I could be using something called a standard map. I'll get to that, but first I want to show just like the way of doing it the way I already did, in C, but with vector instead, so you can kind of see a one-to-one parallel. So I'm going to load the file. I'm going to create a standard vector of type map, so vmaps, let's say. Okay, so this weird syntax here. Standard means it comes from a namespace, like namespace std, right? Someone did this, and they wrote some stuff in there. You can put variables in there, you can put a class in there, you can put a function in there, whatever. And I haven't showed enums yet, but you can put enums in there. But yeah, all this stuff gets scoped into this std block. So if you want to reference it, you have to put std in front of it. What you could do is you could say using namespace std, and then I wouldn't have to type std. Personally, I don't like to do that, because if more than one namespace defines something, then it can cause issues when you're trying to compile it. It'll be ambiguous, and the compiler won't know which one to use. Or sometimes it'll just pick the wrong one and not tell you. So anyway, that is what it is, right? So I'm just going to type it out every time. You guys can do it differently if you want. Now, the syntax here, you notice we have vector angle brackets map. So this vector type can essentially hold an array of elements that's dynamically sized. It starts out with no elements, but each element has to have a certain type. You have to specify the type you want here. So this is a vector of map structures. So each element is going to be one of these structures. Now, the way that it stores these is with a contiguous block of memory. So like before, when I actually allocated these, I counted the lines, and I allocated one giant block of memory that's equal to the size that I need. However many structures I need, it's that many structures long. The vector is going to basically keep reallocating the block every time I add a new structure to it to make it bigger. And you can do that with like realloc, right? So I showed malloc, I showed calloc, I showed free. There's also realloc. There's also like a alloc A, I think it's called, that you can do for stack allocation for small things. That's kind of nice sometimes. Anyway, it's essentially reallocating the block and making it bigger. This one, you let's say the pointer equals, you have to typecast it. So some type pointer, realloc, whatever the old pointer was, and then new size. That's how that one works. So vector's probably doing something like that in the background. At this point, I don't need to actually count the lines anymore. I don't care about that. I don't care about iterating through these anymore. I will start at the beginning. I will count, or not count, but I will look for the end of each line. And yeah, right here, all I have to do is I'm going to say that, what do I call it? vmaps? Is that right? Yeah, vmaps. Okay. I'm going to say .inplace back. So this is going to put something at the end of the list. So every time I want to add a new map structure, let's call it m, or lowercase map, whatever. So map dot, let's see, key equals p, but I need to make it a standard string, so can I do that? Yeah, it'll automatically happen. I want to make this more obvious later, but when you make a standard string object, it has a lot of ways to create the standard string. You can say start at this character in memory and end at the character before this character in memory. So you're going to end at this -1. So if I do this, the range is going to be p, comma, e like this, not inclusive. That's one way you can do it. You could also just say standard string equals p. So if you do that standard string constructor with just one element, it's going to say this is 0 terminated and go till you find the first 0, which is what I'm doing. I already zeroed it. So this constructor will work. I'll talk about constructors, I'll talk about class and stuff later. Right now I just want to show what you can do with these containers and how much easier it is. But I'm using this constructor right here. So anyway, map se value equals, and it's going to be LPC token. Using the same constructor here because there's a 0 after the value. So this would be the 0 after the key. This would be the 0 after the value. It's going to see those and it's going to stop the strings there. Now what I can do is I can just say add the map at the end of the vector. Don't need that anymore. What else? I don't need this anymore. So the thing about vectors is, as soon as they go out of scope, they automatically free their memory. So just like I'm managing this buffer here, this block of memory, and having to free it myself, the vector stores information about that block of memory in itself. So this variable right here, when it goes out of scope, like this is the start of the scope, the end of the scope is right here when the function ends, it's going to automatically free the memory it holds. It does that for us. So that's really cool. It's a great reason to use a map. So in this case, there's a different way we can iterate through this. I'm going to show a kind of a dumb way first, because I don't want to get too crazy with how I'm iterating. I'm going to say it equals 0. It's less than vmaps.size. I don't like that it's called size, because to me I think of the size in bytes, but it means the size in elements, which really means the count. I would have called it count or length or something, but they called it size. It's pretty much consistent across all the standard C++ containers. I think it was a bad choice. I always use count, but you know, it is what it is. So let's see here. Maps. Okay. And this should work the same, unless I'm just forgetting something silly, which I might be. Oops, let's see. I'll put passer, not parser. Jeez. Okay, it does not name a type. Really? It should. The type should be a size t. Okay, so whatever name st key. Oh, right, it's stir now. Oops. Okay, so right, I changed these to string objects. So here's the thing with these. With a standard string, it's kind of like a structure. You can't print out a structure like it's a string. To get the string out of it, you do C stir. So you have to add this extra step here. Jeez, I cannot type today. Okay, so we're getting the string out of the string object here. So this is standard string C stir. So that's the type, and then this is like a method inside of it, or a function, whatever you want to call it. And that's going to return a const char pointer. I think that's why it's called C string for constant. Now, it's interesting because before C++ 11, strings were not guaranteed to have contiguous memory, but when you return to C string, it must have allocated a new block or something if it needed to return to you. I'm not sure exactly how that's supposed to work, but anyway, there's now also a string data where you can, I think, manipulate the data, and it's guaranteed to be contiguous after C++ 11. Anyway, let's give this a try real quick. So what else is it going to complain about? So I'm still using LP current map somewhere. I shouldn't be. Line 72. Let's start with that. So map. Right, it's stir key. Oops. Okay, what else is a problem? 77 has one. Okay, yeah. Don't really need that anymore. We'll do nothing. What? Come on. Okay, 82 is the next one. I'm just looking at these line numbers, the errors happen. Expected qualified ID before 4. So you have an extra thing here to sort of the scope. This is the while loop, I think. It is. Did I not start a new scope here? That's why. Yep. Oops. There we go. Now it's happy. And it did not work. So let's find out where the problem's happening. And here, people are really going to get their dander up, right? I'm going to start doing this. Did we crash yet? My guess is we don't make it this far. I'll put a bunch of 2s here. And then let's do that. Put a bunch of 3s here. And we'll just check to see how many of these outputs we get. None. And that's because I'm using GCC, which does not automatically flush after every output like Microsoft Visual Studio does. It's more aggressive with that. So flush and output. I'm going to just copy that. Flush here. Really? That's interesting. Why would it Let's do this then. 0, 0, 0. Flush. Standard output. Really? What is going on? There must be something it's creating that when it gets instantiated, it's causing a crash. I'm not assigning like a string to 0 or something weird. So where's everywhere I'm using the maps? So I'm placing back a map. Yeah, which has 2 strings in it. That's fine. What's the map size? Uh-huh. Yeah. That should be fine. Well, let's do this. Start coming out a block of code. So it gets further now. At what point is this crash happening? That's what I'm wondering now. So if I do, let's see, point to the start of the block, find the line break, in the string at the line break, find the equal sign, okay. If it can't, then it leaves. Which really, in this case, I should also be freeing the buffer. Okay, let's make the equal sign be a 0, go to the first thing after the equal sign, create a new map. This structure has 2 strings in it. Just for fun, let's comment that out. It shouldn't have any issues. Unless it's actually getting a pointer to 0, but it shouldn't. Neither of these should ever be 0. Go to the next line, okay. Then we end the new scope here. Because we never actually filled this, that should be fine. It should have no size. Let's see if that causes the problem. So that is where the problem happened. So at this point, I know the error is happening here. It's probably in one of these. So before I print either of these out, I'm going to say key location. Sign P. Okay. I'm going to do P. Okay. I'm actually going to put this one down here. I'm going to say value location. In this case, it's going to be LPC token, right? I didn't flush the output. Oops. Okay. Really? This is kind of perplexing. What if I just do that? Actually, can't. I do that. So that does work. So why is it that I can't even show where the key location is? Like, yeah, it has real memory address. And as soon as I do this, no, it's not that one. Okay. All these have real memory addresses. So it must be, I do this. No, it's actually adding it to the map. Why would this be a problem? Why couldn't it in place back? Why would that crash? Is this an issue with the version of C++ I'm compiling it with? Why would that be an issue? Place back map. Yeah. The type is map. I'm like perplexed right now. What the heck? Let's do that. No, that's not the issue. What the heck? The vector of maps. There's nothing weird going on here, it's just strings. And I'm moving it in. Why would it crash on that? I am like perplexed right now. Like seriously. Let's try something else, like if I do insert, I'll just do this. I'll say v maps in. So after the last element, we're going to insert it. I'll say map. Insert that value at the end. Nothing. Really? Okay. How about the maps dot push map? Nothing. Wow. Huh. Why would that cause an issue? Okay, well, before I get too wild with this, I'm guessing there has to be some issue with the pointer I'm passing to these strings that I'm copying over. I don't believe that the map is broken. I mean, the standard vector. Like, that can't be the problem. Contents. So, I'm actually going to show the contents at P. In fact, I'm going to do the same thing here too. I'll say, yeah, contents. Yep. Okay. Just showing the contents is causing a problem, huh? Because I'm not actually putting it in the app anymore? For the vector, I mean. Let's not copy either of these. So these are real contents. Nothing here looks weird. Why is this a problem? Huh. Yeah, every single one of these looks like a real string. I don't see any empty or anything. What is going on? Why is this an issue? Just out of curiosity, I'm going to try running it in a different terminal. Okay. I can put these in. Let's try running the weird. It does still. Jeez. It's the issue with Git Bash. It was working. Like, that was driving me crazy. Wow. That's really something. The instant I use standard vector functions, it just stops working on Git Bash. I can't imagine why that would be. How bizarre. Well, I may have to start doing some of these tests in a different environment. I wanted to keep it as simple as possible. Just write everything with Nano. I could, I guess, SSH into my server and use a real terminal instead of using this Git Bash window in Windows. I don't know. I could swap between the two terminals as well. Anyway, what did I remove here? Pushback, insert, yeah, okay. Pushback doesn't let you move stuff easily. I want to move from the map. And I could just make a constructor for it, make it move more easily, but I'm gonna leave it like this for now. Yeah, that's just so weird to me. Because it's absolutely working. Yeah, I'm gonna get rid of some of this debugging information about where I'm copying stuff from. We don't need this anymore, don't need that anymore, don't need this anymore, don't need that anymore. Yep. Not hard to see. Okay. That's the whole file. This is the key value, key value, key value, key value, key, yeah, okay. Nothing's empty. And you see, I didn't have to truncate it here either, because the size of the string that I'm putting in there is dynamic. It just goes up until the first 0, so it allocates as many bytes as it needs. And that was the case too. If I go into my earlier example, go into CDIR, it was, well, I call it parsing in C. Okay. So if I look at this old parser right here, it also, by the end of it, let us do the whole thing. There was no truncation needed, because I just pointed to the position in memory of the start of each key and the start of each value, which already ended into 0. And then I'm just printing from that position in memory up until the first 0, because that's what %s does, and it's, you know, printf or fprintf, you know, file handle, %s, right? That %s right there is telling it to go to the first 0 from whatever memory address you pass, LPSC string. Anyway, yeah. I'm a little bit bummed about that, man. That's kind of annoying. I don't know why Git Bash is having that issue. I've seen it before. Whenever I include IOStream, I try to do that. Like if I do a project like, let's say, this will be a little bonus here. IOStream, main, void. I do something like standard cout. I'll say this is a test. I don't have to do that. I could do it the real C++ way, right? Make it even slower. Okay, test, okay. I do test, run it. Look, couldn't even compile it. So there's something going on with this compiler. If I actually run that compiler through the PowerShell, though, I run it, it works just fine. So I'm kind of thinking maybe the environment variables I have for Git Bash are somehow different, or it's like linking against the wrong DLL files or lib files or .a files or whatever. I'm not sure. Probably an environment issue. Maybe it's not even Git Bash. I'm just, you know, mistaken here. Let's see if I run it now. Yeah, segmentation fault. It's just trying to link against the wrong DLL or something. Because if I compile it on this, like it's working. It lets you compile it and it works. If I try to compile it over here, it not only won't compile, but if I try to run it compile with something else, it's not working. So there's definitely something going on with the environment with Git Bash. Whatever, I don't care. It's not like a real development environment you'd use for a big project anyway, but it is just kind of annoying. So the main reason I like Git Bash is because I can use things like grep, I can use Nano, find.name, or my dates and stuff. It has a lot of things I like. So I'll use it for what it's good at, and I'll not use it for things it's bad at, I guess. But let's do a brief overview, because this kind of got derailed here. So there's a string container, which lets me store, instead of like a char asterisk buffer that I have to actually allocate, maybe, by doing like malloc or calloc or alloc. Maybe not alloc probably, but I could do realloc. And I have to, you know, free it when I'm done. Instead of that, I can basically get the size of the string at any time. I can make the string longer by concatenating to it without having to worry about overflowing a buffer, like an array of elements that only has so much space. This just covers all of that for me. It makes it so much easier. And I don't have to worry about freeing it, because when it goes out of scope, the string will just automatically free the memory. Same thing with vector, but vector is more for like structures. You could use it for primitive types too, like you have an array, a vector of ints, right? Just like an array of ints. However, I typically use it more for things like structures. And again, it'll free the block memory for you automatically, which is just really nice. I like that you can scope things. As soon as the scope ends, this map will be freed. And it includes center strings inside of it. Well, as soon as this is freed, this container, everything in it gets freed too. So it calls the destructor for this. In the next episode, I want to talk about classes and I think constructors and destructors, and I don't know if I'm going to copy everything, or not copy everything, if I'm going to mention everything like copy constructors, move constructors, and assignment operators, but maybe I'll go through all of that. I don't know. I'm at least going to go through constructors and destructors, so I can kind of explain like what's happening and how stuff's being stored and freed. But suffice to say that the advantage here was I was able to copy things really easily and have its memory be freed without having to think about it. And over here, I was able to make as many nodes as I needed in the file without having to count any lines or think about like how big I need to make it to have enough size. I just added the space as I needed it, which, I mean, it is slower, but this code's way easier to reason about and like maintain and debug than the code that I had previously in C. It's just a lot easier to work with. I kind of want to leave this debug stuff in here just because if I ever post it somewhere, you guys can try it out. These will do the same thing as in place back. However, in place back can use a move constructor, which is a bit faster. It doesn't have to make a new object. It'll kind of like use the same object and just move its internals over. I don't know if I worded that right. But just to say that a move is faster than creating a new object and copying everything over. But yeah, so instead of looking at the current node I'm on and moving forward by a node each time, I'm just creating a new node and resizing the vector to fit that node and copying the data into that node. And then I just loop through all the nodes that I have inside the vector. Yeah, inside the vector. There's other ways I could iterate through this. Typically you wouldn't do this. You'd probably do something like this instead. You'd say for standard vector of some type, the type is map. You'd say like, I'm not going to modify it to its const iterator. It equals, maybe v maps dot begin. Actually, it's c begin because it's constant. All right. You would say the iterator is not equal to v maps dot c end, not c med, c end. And we say it++. And in this case, you wouldn't have to index into it like this. What you would do is you would just say the iterator. You dereference it with this arrow operator. This is kind of silly because if you do it dot, this it is kind of like a structure. It's actually like a class object, but it's acting like a structure. But there's an operator overload that lets you do an arrow, and then you can get at the members inside of the object. This is, like I said earlier, it's the same as dereferencing it and then doing dot. Maybe I'll show it both ways here. I'll show it arrow that. Those do the same thing. Dereferencing it and using dot, same as just using the arrow operator here. But that's how you actually get into the contents of an iterator. So that's one way to do it. I'll run that so you can see it works. Although it's not going to work on this window. Yeah, right. So that was test. Oops. I'm actually going to compile it and run it over here, I think, just to be safe. So G++, we're going to do parser LCP, show parser. Ooh, not parser, just parser. And what did I do? Okay, 118 unqualified for if. So this is line 118, Nano plus 118, parser LCP. So what did I do that was incorrect here? What's it complaining about? What's it really upset about? Oh, because I never did open curly brace. That would do it. Okay, parser. Okay, so you can see it's still looped through it. And there's an even easier way to do it now with modern C++. So instead of, like, I'll even just comment this out. So if anyone wants to try any of these, they can mess with it. I'm just going to copy this piece. And you can do for, we're going to say const auto reference to a map object, right? Colon, so the whole range of vmaps. So what this is saying is, for every element in maps, give me a reference to it. So now, because I have this map, and I'm getting it by reference, I can treat it just like it's the actual map and. Just like I have map m, it's like this. Whereas before, the iterator kind of gave me some kind of container, which I had to like dereference to get from like some kind of map iterator or whatever. There's actually standard vector map iterator. I had to get from that to map. And from there I wanted to actually get its members. So what I could do here is if I do this operator right here, that would give me, let's see, that would give me the map, yeah. And if I do this arrow operator, not only is it giving me the map by doing this, but it's also giving me the member. So it's like arrow member. So like, how do I word this? I'm trying to think how to do this easily. I just have some type pointer, let's call it x, okay? If I do, it can't be, it has to be a structure though. Like, imagine t is a structure, right? So if I do tx arrow member, what I'm doing is really dereferencing that pointer and saying dot member, right? So I'm saying here, basically dereference, so tx, and then I'm saying from that tx dot whatever. So one way to look at it is if I copied it, if I said t, just like the actual type, this is like, let's say lpt, right? This is actually just a type t called t. Say it equals this lpt, right? Dereferencing it, I'm getting the actual type from the type pointer, right? Then I could say like the type t called t dot some number. It's kind of like that happening in one step, because I'm not actually copying it. I don't know. I'm just trying to think of how to like explain in a way that makes sense. Either way, this is like having the actual map element. You know, there was another video where I explained passing arguments, like if you have some function foo, you could do tn something, right, like const tn. And I was saying, like, when you pass it by this, you can use a dot, like t dot member, right? And if you passed it by a star, you'd have to do t arrow member. I mean, that's basically the same thing that's happening here. With this kind of reference, you're treating it like you defined the variable here. Like if I did tt, it's like that's happening, except this didn't happen here. It happened outside the function, and then I passed it foo t, right? That's what really happened, but it's like this happened. So, anyway, this should work as well, and this is way easier to type. This is like the modern way of doing it. Almost everyone does that now. Okay, it's not gonna... There we go. Let's do it in here. So you can see that worked as well. So if you want to do it the modern way, this is what all the cool kids are doing now. If you want to do it an old style way, you can do this with a constant iterator, or if you want to do it just based on the size of the map and index into it, you can also just do this. And if you notice, I did treat that variable v maps just like an array, right? And I took that element of it. So you can totally do that. A lot of standard containers have that option. So another one you can do that with is standard deck. Standard deck. Standard deck does that. Standard vector does that. Standard map does that. However, for a different reason. I'll get into that maybe in a later episode. Yeah, I've already gone on for way too long, I think. I'm actually tempted to kind of redo this, but I kind of don't want to. You got to see me debug an issue with the console. And honestly, if I leave that in there, maybe someone will actually know what the issue is, if it is an environment problem, or if they also experience a similar issue with their Git Bash. I don't know. Anyway, this shows you how to use the standard string object, how to use standard vector, how to avoid counting things and just add elements on the fly, how it manages memory for you, which is really nice. So yeah, I think I'm going to leave it there. If you have any questions or comments, please do let me know. And I guess do what you can to boost the algorithm for YouTube, right? Like, comment, subscribe, all that kind of stuff. I'll catch you all later.